Salam sejahtera to Madam Hadijah Ahmad. So today we will present our project proposal, which is on suction skimmer. So our project is based on SDG 6, which is clean water and sanitation. Our group members consist of 4 people. So my name is Augustine, Julian, Anak, ID CC19149.
My name is Luqman Hakim, bin Saiful Azwal, CC 19260.
My name is Iman Hajar Merican. ID is CC1917.
My name is Muhamad Amin bin Fauzi, EB 19268.
So firstly is for introduction. So our project is based on the SDG 6, which is mainly for the sea and anything that's related to the ocean. So throughout the years, oil spill has been occurring which harms the aquatic ocean and maritime industry. As you can see on the slide is the one of the example that has been collected from the internet from the an article. So this is the area on the picture on the right side is indicates where the oil spill area, which is more to the lagoons and surrounding beaches, and the second image is the suction skimmer that is used and the existing product that we will innovate throughout this project. So this is our sustainable development goals, which is the clean water and sanitation. Our proposal is made based on this SDG, and the definition of this SDG is that ensure availability and sustainable management of water and sanitation for all. So our target will be target 6.3, which is improve water quality, wastewater treatment, and safe reuse. So this is our problem statement. The product that is existing, which is the suction skimmer, has 3 main vulnerabilities, which are vulnerable to clog by debris and ice, requires constant skill observation, and do not operate well in rough and choppy water. So we have conducted one of the problem analysis, which is 4W and 1H, what, when, where, why, and how. For the next part is the CEC analysis. So we found out that the problem of the suction skimmer is less effective to clean a spill. So the reason is stated as in the slide. We found out that the most relevant problems and the root cause are the ones that is in the box, which is the design of system engineering poor and less efficient if the water is rough and choppy. So for the next part, I will pass to Luqman.
Okay, continue to the component analysis. Here is our innovation product, and the product will be used based on the suction skimmer or another type of skimmer that is a wear skimmer, where it's shaped like a basket. So when the seawater level, we put it in the sea or any parts that are contaminated, and it will suck out the oil from the upper lip of the wear and into the filter. The filter is made by hair, which is genuinely oleophilic and hydrophobic, where these substances will absorb the oil, so there are no needed use to collect the oil and put it in the another storage. So the pressure pump will suck all the contaminated water, and it will suck it from the bottom, and then the oil will be trapped in the hair filter. There will be 2 sections of the filter, and when the oil is trapped inside there, the water flow will go up the hose and exit throughout the water release. And for here, we have the super system. There are the debris, ice, and rough or choppy water. This super system will affect the product, and it will cause major problems such as the filter will not operate efficiently, and for the rough choppy water, the basket won't stay stabilized. And here I will pass it to Iman.
So this is the interaction analysis. So first of all, the lip of wire will be attached to filter, and the filter will hold the basket, and the basket will be attached to the hose, and the hose will be attached to pump. For the function model, the super system for the ice, the lip of if there's ice, it will affect the lip of wire. And for the debris, it will be clogged in the filter. And for the basket will not be stable if there's rough water.
Okay, for the system parameter, here we have the manipulated variable, the positive responding variable and the negative responding variable. So for the manipulated variable, we need to manipulate to improve the design for the pump or air suction system. The positive responding variable, the oil will be recovered by the pumps or air suction system directly from the water surface more efficiently. So there will be no water inside the storage that we will keep the oil. And for the negative responding variable, it's more vulnerable to becoming clogged by the debris and ice. So for this parameter, we will use the 39 parameters and the 40 inventive principle. So here we have the quantity of substances in the y-axis, and the x-axis have the object generated harmful factors. So the positive side will be the quantity of the substances will be much more quantity, it will be safe, and for the object generated harmful factors is where the negative side it is. So we have the IP for the 40 principles is 3, 35, 39, and 40. Based on what we had, the local quality of the system of the IP3 is more suitable, where we can use it as in upper filter on top of the skimmer so that it will block all the debris. Next, I pass it to Zul Adnin.
As for the engineering contradiction, three variable, which is manipulated, positive responding, and negative responding. So for the manipulated variable, improve the design for the pump or air suction system. The positive outcome or the positive responding variable, oil will be recovered by pumps or air suction system directly from the water surface more efficiently. So the system parameter 36, which is quantity of substance. For the negative responding variable or the negative outcome, the system will be vulnerable to becoming clogged by debris and ice. The system parameter 30, which is objective affected harmful factor. So for the engineering contradiction, if improve the design for the pump or air suction system, then oil will be recovered by pump or air suction system directly from the water surface more efficiently. But the pump or air suction system vulnerable to becoming clogged by debris and ice.
So that is all from our group. Thank you.